more and more so, we have to understand multi-protocol BGP. Now, multi-protocol BGP is BGP and kind of the next evolution of it. It's still fundamentally capable of advertising BGP routes. But when we say multi-protocol, one of the key differences is the fact that we get into things like address families and neighborships can occur over anything that we have communication with. So let's say we wanted to advertise IPv4 and you had neighborships pointing to IPv6 addresses. That can work. Vice versa. You could do IPv6 routing exchange over neighbor statements that are IPv4. Now, what are the issues? You might have inactive neighbors. You have to make sure that your neighbors are active. And you also have to understand that you can get into a situation with the next hop where you say, okay, well, I just learned IPv6 routes over an IPv4 neighborship, and we told you we could do that. But there's a caveat, and that is the routes are unusable unless you fix the next hop IP address that you're getting. Because the next hop IP address looks like an IPv4 address. Wait a minute. That isn't going to help you reach an IPv6 destination. When we look at BGP communication, BGP config, here's some of the usual suspects for multi-protocol BGP. Let's say we get into an address family, IPv6 unicast. We're saying, hey, I want to get routing information for IPv6. And that is going to be done over a v4 neighborship, which we have to make sure we activate. Okay? So we do those things under address family configuration mode within the BGP process. When we think about neighbors, they have to be activated within an address family. And this is just something to get used to, quite frankly. It's almost like doing a no shutdown command on the neighbor. So let's say you're working with multi-protocol BGP, and for some reason that neighbor just isn't doing squat. You don't see it with show IP BGP summary. Well, make sure you go inside of the address family and type in neighbor followed by the address in question, the address of the neighbor. And then you say, yeah, I do want to use this. So you say activate. One of the reasons why this happens the way that it does is because we can have neighbors in outside of the address family. And it doesn't automatically cascade and inherit the config of the major BGP process to the address families. This is kind of what says, yes, I do want to inherit that neighbor. The activate command does that. If there were one thing I was going to show you about multi-protocol BGP, it would be this, and it is the fact that you might have v6 routes being exchanged over your carrier protocol at v4, and you would get that if your neighbor command was pointing to an IPv4 address. You get into the address family, activate that neighbor, and it's the v6 address family. Here's the deal. IPv6 just basically can't work with an IPv4 next hop address. And so here is the config to fix it. Now, the way that the T-Sheet exam works is not that you have to type in a lot of commands to fix things, but you have to know what the cause and the appropriate resolution steps are. So what we have here is a prefix list that says, hey, basically anything. And it says then, I want to match that prefix list, and if that happens, set the next hop to this address. So when I receive routes from this neighbor, this is the situation in question, v4 neighborship for v6 routing, I am going to modify the next hop for routes that are conveyed over this neighborship. And the next hop then is transformed to a usable, presumably, a usable v6 address. So that's not something you would expect. Definitely not something you would just assume. You got to really know unusual facts sometimes in the world of Cisco, and this is one of them.